Your quiz tomorrow is on sections 7.1 and 7.2. The formula sheet that you see here is going to be given to you tomorrow. So you'll have your reciprocal identities, your Pythagorean identities, your sum and differences of sine, cosine, and tangent, and your unit circle. So you'll have all of that given to you tomorrow. If we look at the first section, we're simplifying these expressions dealing with those, functions. So for number 1, we have 1 minus cosine squared theta over cosine squared theta. If you look at those Pythagorean identities on the first page, you see that that sine squared theta is equal to 1 minus cosine squared theta. So we can change that numerator out to just be sine squared theta over cosine squared theta. And we know that sine over cosine is tangent, so this simplifies to just be tangent squared theta. For number 2, you have cosine x times secant x all over cotangent x. If you want to write this as a division problem to start with, you can do so. You're just going to have cosine x times secant x divided by cotangent x. So secant is the same thing as what over what? 1 over cosine. So this is also cosine x, or cosine x over 1, times 1 over cosine x divided by cotangent is, in terms of sine and cosine, cosine x over sine x. For this one, for the first set of parentheses, you have cosine x over 1 times 1 over cosine x. They are reciprocals of one another, so this just leaves you with 1 divided by cosine x over sine x. When we divide fractions, what do we have? Keep, change, flip. So that's 1 times sine x over cosine x, which is also what? Tangent. For number 3, we have cosine theta times secant squared theta minus cosine theta over secant squared theta. If you look at the top of this fraction, you have cosine theta and negative cosine theta. Those two are opposites of one another, so they cancel each other out, and you're just left with secant squared theta over secant squared theta. If we have the same thing over itself, what is that equal to? 1. For number 4, you're given tangent x plus cotangent x all over tangent x. I would first write this as a division problem. So you have tangent x plus cotangent x divided by tangent x. In terms of sine and cosine, because they are more simpler than tangent and cotangent, what is tangent? Sine over cosine.
Is it never going to be 1 over cosine?
1 over cosine is your cosecant. For cotangent, it's cosine over sine. So you can rewrite your cotangent x as cosine x over sine x. And then your tangent x in your denominator is the same thing as sine x over cosine x. From here, in order for you to add your two fractions in the first set of parentheses, you need like denominators. So you're going to multiply the top and bottom of the first fraction by sine x.
You can't just simplify that?
No. Your second fraction in there is going to be multiplied by cosine x. Because again, you're working with fractions, and adding and subtracting fractions, you need like denominators in order for you to combine those two fractions. So this is going to give you sine squared x plus cosine squared x all over sine x times cosine x divided by sine x over cosine x. Now, you can't simplify anything with that fraction on the left-hand side. However, you can keep, change, flip here, and then multiply by the cosine over sine. So this is, if you do that, would give you sine squared x plus cosine squared x all over sine x times cosine x times cosine x over sine x. Is there anything that cancels out before you multiply straight across? Your cosine. So these both cancel out. You're just going to be left with sine squared x plus cosine squared x all over sine squared x. Now, if you look at the Pythagorean identity part with that first table that's given to you on your formula sheet, you have something on there that cosine squared theta is equal to. Change that cosine squared theta out, or cosine squared x out, to be working with just sine. If you change that cosine squared x out to be 1 minus sine squared x, that's going to leave you with sine squared x plus 1 minus sine squared x all over sine squared x. On the top, you have two terms that are opposites of one another, the sine squared x and the negative sine squared x. So those two, since they are opposites, they cancel, and you're left with 1 over sine squared x. Now, if you're simplifying this fraction isn't pretty, so write it as a whole number. What is the same thing as 1 over sine? How about secant? Is it cosine or cosecant? It is cosecant. Okay, so it's cosecant squared theta, or x, is what this 1 over sine squared x is equal to. The next part that you're going to look at, you are verifying. So with number 5, you have tangent x times cosecant x times cosine x is equal to 1. If you rewrite this in terms of sine and cosine, that tangent x is what? Sine x over cosine x. The cosecant x is the same thing as 1 over sine x, and cosine can stay cosine x, or put it over 1. What cancels? Your sine x cancels with sine x. Your cosine x cancels with cosine x. So it's just 1 is equal to 1. For number 6, we are given tangent squared theta times sine squared theta is equal to tangent squared theta minus sine squared theta. There is a minus sign there on the right-hand side. Keep that in mind. Again, I don't want to work with tangent. I have sine in there. So I want to work with my more simpler terms, so I'm going to turn the tangent into sine over cosine. This is going to give me sine squared theta over cosine squared theta times sine squared theta over 1 is equal to sine squared theta over cosine squared theta minus sine squared theta over 1. In order for me to add or subtract fractions on that right side of that equal sign, I need like denominators. My least common denominator between those two fractions is cosine squared theta. So I'm going to multiply this top and the bottom of that second fraction by cosine squared theta. This is going to leave me on the right side with sine squared theta minus sine squared theta times cosine squared theta all over cosine squared theta. As you look at this numerator, both of your terms there, one is the sine squared theta, the other is the sine squared theta times cosine squared theta. Both of those terms have a sine squared theta to them. So you can factor out the sine squared theta. So that would leave you with sine squared theta times 1 minus cosine squared theta all over cosine squared theta. If you look at the other side of your equal sign now, you're very similar to what you have there. If you did multiply that other side of your equal sign, you would have gotten sine to the 4th power theta over cosine squared theta. So if you continue to work with that right side to make it exactly what you have on the left side, what are we going to have? Well, that 1 minus cosine squared theta, if we look at those Pythagorean identities, is also equal to sine squared theta. So that's the same thing as saying sine squared theta times sine squared theta all over cosine squared theta. The sine squared theta times sine squared theta, again, is going to give you sine to the 4th power theta over cosine squared theta. So are the two sides of your equal sign the same? Yes, they are. If we look at our next question, we have sine over 1 minus cosine is equal to cosecant times 1 plus cosine. The 1 minus, oh, here, how about this? The cosecant is what? One over sine. I'm going to use theta for this. Okay, so from here, what else can we do? Would this be the same exact thing as saying 1 plus cosine over sine if we were to multiply? Is that the same thing as your other side? No. What do we say when we have fractions like this, where you have one fraction times another fraction, or one fraction is equal to another fraction? What can we use? Cross multiply. That would give you 1 minus cosine times 1 plus cosine is equal to sine squared. The 1 minus cosine times 1 plus cosine is a difference of squares, so that turns into 1 minus cosine squared. What is this? One of your Pythagorean identities. If we look at the next page, you have sine 285. Is 285 degrees one of those angles on your unit circle? Nope. What can equal to the 285? So we said that for this one, I'm going to use the 60 and the 225. So I'm going to use the 225 and the 60. So sine of 225 plus the 60. We're working with addition of sine. So look at your formula and use the correct formula. Just plug in your values. Remember, sine is your, let's do this. Put this here. Sine is y. Cosine is x. Tangent is y over x. Or y divided by x. So keep those in mind. So if we're using addition with sine, that means we're going to have the sine of 225 times the cosine of 60 plus the cosine of 225 times the sine of 60. Look at the order pairs that go with the 225 and the 60. For 225, what is your y value? The negative square root of 2 over 2. Okay. What is your x value of 60 degrees? 1/2. What is the x value from 225 degrees? And what is the y value from 60 degrees? So first thing to do here, multiply these out. The negative square root 2 times 1 is the negative square root 2. 2 times 2 is 4. The negative square root 2 times 3, the square root of 3, is negative square root 6. And 2 times 2 is 4. If we bring all of this together, this is going to give us the opposite of the square root of 2 minus the square root of 6 all over 4. If we look at number 2, we're taking the cosine of 285 degrees. So since we used the 225 and the 60 for the first question, for this one we said that we're going to use the 240 and the 45 degrees. So we're just going to take cosine of 240 plus 45 degrees. So cosine addition, we're using this formula here. So that's going to be the cosine of 240 times the cosine of 45 minus the sine of 240 times the sine of 45. What is the x value on 240 degrees? What is the x value on the 45 degrees? Minus the y value on the 240. Y value from 240. And the y value from 45 degrees. So if we multiply these, we're going to have a negative square root 2 over 4 minus the opposite of the square root of 6 over 4. Double negatives equal positives, so that's a negative square root 2 plus the square root of 6 all over 4. If we look at the next section, it tells you that for the following to write each expression as the sine, cosine, or tangent of an angle, then find the exact value. For number 1, you have the sine of 210 degrees times the cosine of 150 degrees minus the cosine of 210 degrees times the sine of 150 degrees. What two angle measurements are you working with? 210, 150. 210, 150. Leave a little space between the two, put them in parentheses. Look at the formula that you have based off of your sum and differences of sine and cosine. If we're working sine and cosine with your first part and you're separated by subtraction, which one are we using? Sine, cosine, positive, or plus or minus? Sine and subtraction. So if we're using sine and subtraction, that means sine goes out front. Subtraction goes in between the two angle measurements in the parentheses. What is 210 minus 150? 60 degrees. So this is telling you to take the sine of 60 degrees. Look back at your unit circle. What is the y value on 60 degrees? Square root 3 over 2. That is your answer. For number 2, you have tangent 300 degrees plus tangent 30 degrees all over 1 minus tangent 300 tangent 30. First off, you have no sine or cosine in here, so automatically you're working with tangent. You just got to figure out if it's tangent with addition or tangent with subtraction. What two angle measurements are you working with? 330. So put them in parentheses, keep a little space between them. Look at your tangent formulas. Which one has addition on the top? The plus one, the addition. So you're going to use tangent outside and addition on the inside. What is 300 times, or sorry, 300 plus 30? So you're finding the tangent of 330 degrees. Tangent is y divided by x. What's your y value on 330 degrees from your unit circle? Negative 1/2. Divided by, what's your x value from the 330 degrees on your unit circle? Keep, change, flip. Negative 1/2 times 2 over the square root of 3 gives us what? Can you simplify anything? What about the 2's? So the 2's become 1's. So really this is negative 1 over the square root of 3. So if we rationalize that denominator, we multiply the square root of 3 on the top and the bottom. And this leaves us with the square root of 3 over the square root of 9, which is 3. So the negative square root 3 over 3. For number 3, you're working with cosine 100 times cosine 50 minus sine 100 times sine 50. What two angle measurements are we working with? Put them in parentheses, leave a little space between them. Are we working with sine or cosine? Addition or subtraction? Opposite. Addition. So 100 plus 50 is? You're finding the cosine of 150 degrees. Cosine is your what value? And what is the x value on 150 degrees?